All right, so we've used the chain rule for two functions, but we can actually use it for an extended set of compositions of functions, so three or more functions. And so example, if y is equal to f of w, and w is equal to g of u, and u is h of x, then we can say, well, dy dx, because we're originally going to have y here, and our final value is x, is going to be what? Well, it's going to be the derivative of y with respect to w times the derivative of w with respect to u times the derivative of u with respect to x. And notice, nice thing to notice here, if it'll let me, that cancels that cancels that, and we get dy dx, which is what we want here. Okay, so now let's see if I can try to make it so it works out like this on our example here. All right, so we have to come up with all the inside outside functions, and we're going to do that. So it looks like we have inside functions, outside functions, and then the very, very outside function. So one function is going to be this. That's kind of the most inner function. Then we have another function is in here. And then our very last one is that power rule. Okay. So maybe we want to call the out one L, and then we can have this one be kind of a E, and maybe we can call this one I. Okay. And so we're going to take the derivative of each of those and work our way out and multiply them together. So what we really need to do is we need to find DL, and again, it's probably going to be, it's going to be DL, D something times DE, D something times, and DI. Oops, didn't write that one like I said it. DI of D something. But that's kind of just a notation I'm going to use here. And so what we need to do is we need to kind of work our way through these. And so first things first, if we look at the very, very outside function, that's going to be 3 brought down here because that's going to be that. So it's going to be 3 times what? Well, ln of 1 plus e to the x. And then power rule says that's going to be now a 2. Now I'm going to take the next inside piece. Now I'm going to have the ln of this piece. So the derivative of ln, remember, you're thinking of this as just ln of x. So the derivative of that is 1 over x. But what's the 1 over x? So that's going to be 1 over e to the x. So that's going to be times 1 over 1 plus e to the x. Okay. And now I'm going to take that times the derivative of 1 plus e to the x. Well, 1 plus e to the x is just going to be the 0 and the derivative of that. And so that's just going to be e to the x. Okay. So now what do I have? Well, I've got 3 e to the x, and I also have ln of 1 plus e to the x squared. All right. And maybe I better put that whole thing in parentheses so we know for sure that that's what's squared. And then over our 1 plus e to the x. So now I have 3 e to the x, ln of the 1 plus e to the x, the quantity squared, all over 1 plus e to the x. Now, if we're putting this in a calculator, we'd probably want to make sure we kept that there, but we're just finding the derivative. So that's kind of be our dy dx in this case, and or y prime, however we want to look at it. So that's y prime. So that's what that derivative is. So we had to kind of look at each of the pieces. We had the power rule first, then we had the ln we had to take the derivative of, and then we had the 1 plus e to the x we had to take the derivative of. Okay, so 3 pieces, we multiplied them together, and then when we got done to the end, we got that as our final answer. All right, let's stop there and we'll come back for more.